Well, hello guys, here Mr. G with another video. This time we're going to be doing a question for the grade 11th related to intermolecular forces. The coming exams is going to be applicable and it could be a little bit tricky. So before that, please subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question was a question paper in 2013. It's quite old, but I think they could be more applicable when they are older. It's better for practice. Okay, grade 11 you can see, and it was done at the Northern Cape province. This time is going to be question 2 related to intermolecular forces. Now the first question 2.1 say, name the type of intermolecular forces involving each of the following substances and explain how each of these intermolecular forces are formed. Now the first one, ammonia. The type of intermolecular force that ammonia is going to have is hydrogen bond. I want you to see the following here. If you have ammonia, you know how ammonia is in the following way. It is one hydrogen, it is another hydrogen, and it is another hydrogen. Okay? Now here, this molecule have a lone pair there that is pushing away all these hydrogen. That is why this one in actual fact is a little bit down as well as that one. This molecule is a polar molecule. Polar, because if you divide the molecule in two parts, like if you cut the molecule on this side here, you have one side that is most slightly negative, positive in this case, and slightly negative. So this is a polar molecule. That is the first important thing you need to know. Second, this is because hydrogen bonds straight to nitrogen. Remember that hydrogen bond happens when hydrogen can bond or can form intermolecular forces straight to either nitrogen, fluorine, or oxygen. So in this case, for you to understand, if we have a molecule, for example, let's say we have two molecules of ammonia and they will look more or less like this. And remember, the nitrogen side will be most slightly negative because have a high electronegativity, and the hydrogen will be slightly positive. So guys, the same happens with the other molecules, slightly negative, and this side will be slightly positive. So this nitrogen here is going to be bonded to one hydrogen. This here is what we call hydrogen bond. That force there, which is an intermolecular force, is what we call hydrogen bond. So this one is hydrogen bond, guys, and what you have to say here. First, you have to say that NH3 is a polar molecule. Second, what I said, hydrogen is bonded to nitrogen, straight to nitrogen. So it's not bonded to nothing else but straight to nitrogen. That is one of the rules there. And just to say or mention, nitrogen have a very high electronegativity. Alright? And the last part you have to say is that the slightly positive of one molecule will be attracted by the slightly negative of the other molecule, which is what is drawn here, guys. This is what you have to answer or explain how the hydrogen bond is formed. I hope you understand. It's not that bad. Now, petrol. And this is the molecule of petrol. This is how petrol look like, guys. This is the molecule of petrol. Now here, what you need to know, this is a large molecule and it's a non-polar molecule. It's a non-polar molecule. So when one petrol molecule, which is a very large molecule, as you can see here, interact with another molecule, the type of intermolecular force that they are going to be is going to be a London forces. London forces, also called dispersion or induced dipole. Now this one, why does it form? Because it's the type of intermolecular forces between, and that is an important point here, is between two non-polar molecules. It's between two non-polar molecule, guys. That is what I'm going to say there, and the explanation is because of the electron. That molecule, eventually the electrons are going to be on one side of the molecule and make that molecule for little time a polar molecule, and that is how it's going to work. I have a video on this one. I will leave the link so you can watch it exactly. And then sodium ion in water. This one is quite simple. You have sodium in water. Sodium is positive and water is a polar molecule. So if you have sodium in water, sodium is a positive ion. This one is a water molecule, and remember, water molecule is also a polar molecule, which one side is going to be slightly positive and the other one is going to be slightly negative. So sodium is a positive ion, guys. So sodium will just be like a circle. For instance, this is Na plus, and obviously it will be attracted to that negative side of the water. So let's move it a little bit there perhaps and do here the force. This is the force there between that sodium ion and that water molecule. And this one is called ion dipole force. And it formed between sodium, or between ions, and polar molecule like water. This, in other words, is like hydration, guys. Alright? So that is the one. So if we go there, this one is ion dipole. This one is ion dipole, and Petrol one, we didn't write it, let's write it here, is London forces. Alright, so that is the first part of the question done and dusted. Question 2.2, if sodium ion in question 2.1.3 above were now placed in Petrol, name the new type of intermolecular forces. Guys, now it's sodium, but Petrol, remember we said it's non-polar. Go back there, it's non-polar. So this one is going to be now ion-induced dipole. This one is ion-induced dipole. What happened here actually? The ion is going to make the non-polar molecule polar for a moment, and the force that keeps those molecules together is going to be called ion-induced dipole. Question 2.3, describe the difference between interatomic forces and intermolecular forces. Now, interatomic forces, guys, interatomic forces is between atoms. For example, this force that keeps the oxygen and the hydrogen together, this one here, is an interatomic force. In other words, is covalent bonding. Those are the interatomic forces. The same happen if we go here. All these ones here, the forces between the carbon and carbon, between the carbon and hydrogen, those are interatomic forces. The forces between molecules is intermolecular forces. So now this force here between these molecules that we spoke about, the hydrogen bond, that is the intermolecular forces, is the force between molecules. Is the forces between molecules. Now, which one is stronger? The interatomic forces is much stronger. So the forces between the atoms is much stronger than the forces between the molecules. We carry on. Question 2.4. Which of the forces mentioned in question 2.3 above is involved with melting and boiling point? Okay, guys, the one responsible for those physical properties is going to be the intermolecular force. The intermolecular force are responsible for the physical properties of the substance. That is important. And boiling point and melting points are physical properties. So nothing to say, is quite simple. How would the boiling point of petrol compare to that of wax? And you can see wax is here, is huge molecule, it's much bigger, guy. So it's very easy. Petrol is smaller, therefore the intermolecular forces are weaker than wax. Wax is also a London force. So the answer here is smaller than. The bigger the molecule, the stronger the intermolecular force. In this case, it's going to be London forces. Now you make this molecule here very large, and there will be more London forces. Alright, so it's quite simple. Give a reason for your answer in question 2.5 above. Alright, what is the first thing we have to say? Both molecules are non-polar. That is very, very important. And therefore they have London forces. In other words, the strength the type of intermolecular forces is the same. The only problem is that one of them is large and therefore is more. So now we have to mention that one as a second point. So we have to say wax is longer. You can use the word bigger, you can use more carbon, so ever. So more side for London forces. There is more side, therefore the intermolecular forces, they are stronger. So the intermolecular forces in wax will be stronger than in petrol. That is important to mention there. Now that it means that you need more energy to break the intermolecular forces in wax than in petrol. So more energy is needed in wax than petrol to break the intermolecular forces. Be careful you don't write the word bonds there. We are not talking about bonds. Remember, bonds is the interatomic forces. We're talking about intermolecular forces. And finally, therefore, higher boiling and melting point. So wax has higher boiling and melting point. Guys, this is the explanation you have to explain here. It's quite simple. Let's go to the rest of the question. Now, the next question says, ice can float on liquid water. What property of ice is responsible for this extraordinary property? Guys, it's density. It's density, and you learn density like in grade 8, so it should not be a problem. You know, the ice have lower density than water, and that is why floats in the liquid water. And the final question, how is this density, we're talking about this extraordinary property of water, is useful in nature? Guys, very simple. I'm not going to write that answer down, but you need to know that because of that property, then life or marine life can exist below under that ice on the pole. So it is very important. It is a very important property of water. And then guys, this one is the end of this question. This one was for grade 11. I hope it helped. The exams are coming, and it will help you to understand intermolecular forces. Thank you for watching. Subscribe for the channel. I'll see you next time. Mr. G here.